In this lesson, we're talking about the distributive property. Your learning goal is that I can apply the distributive property to multiply a term by two or more terms inside brackets. Some key terms you want to remember or know when we're in this lesson. First is coefficient. That's the number that is multiplying the variable. So when you see 2x, the 2 out front of the x is the coefficient. Term. A constant or a coefficient with a variable are terms in an expression or an equation. Let's take a look at a couple of types of problems that you should have seen already, but just as a refresher. When we've got something like negative 2x times 6x, we're multiplying both the coefficients times each other, but we're also multiplying the x's by each other. So in this case, negative 2 times 6 gives us negative 12, and x times x gives us x squared. Similarly, if you've got negative 2x times negative 6y, our signs are going to change. We've got a negative times a negative, so we know we're going to end up with a positive. And again, we're going to multiply the coefficients, 2 times 6, giving us 12, and x times y, giving us simply xy. Let's try some quick questions here as a warm-up. 3x times 5, we're going to take that 5 and multiply it by the coefficient out front of the x, which will give us 15x. 6x times 2x, we multiply the coefficients together, first of all, 6 times 2, giving us 12, and x times x gives us x squared. 3x times 5y, multiply the coefficients together, 3 times 5 gives us 15, and the x times the y gives us xy. 2x times 3x squared, we've got the 2 times the 3, that gives us 6. Then we've got x times x squared, which gives us x cubed. Remember, when we're multiplying like bases, we keep the base the same and we add the exponents. So there's a 1 on the x, so we're going 1 plus 2 gives us that 3. 2x times 3x squared times 4. Let's multiply all the coefficients together. 2 times 3 is 6, times 4 is 24. X times x squared is x cubed. 2x times 3x squared will give us 6x cubed, and then we're multiplying times 4y, so we're going to get 24x cubed y. 3 to the 2a, so maybe so you can see this a little better, it's 3 to the exponent 2a times 3 to the exponent 4a. We keep the same base again and add the exponents. 2a plus 4a is equal to 6a. Going to save that one for another day. Let's look at a very tangible approach here. I've got 3 lunch bags. If each lunch bag contains 1 apple and 3 cheeses, how much do I have in total? And how could we represent this algebraically? So you've got each lunch bag. It's got 1 apple, 3 cheeses, and it's fairly easy to see that we've got a total of 3 apples and 9 cheeses. Algebraically, if you think about it, this is representing 1 bag, and this is saying we have 3 of those bags. So 3 times bracket 1a plus 3c is how we would represent it if we were relying on the distributive property. Or we could multiply it out and have 3a plus 9c. Back in grade 4, when you were asked to multiply a 2-digit number by a 1-digit number, for example, something like 23 times 4, how did you approach this problem? Your first thought was probably to solve the problem using the vertical algorithm, which meant you wrote 23 times 4 underneath it, and you did the calculation, and hopefully you came up with 92. But if you're lucky, your teacher may also have taught you that multiplication can always be shown using a rectangle, like this. Now you just multiply each of the squares in the rectangle. 4 times 3 is 12, and 4 times 20 gives you 80. You add the 80 and 12 together, and you end up with 92. So you can see that you get the same result either way. But using this approach makes the numbers easier to do quite often. 4 times 3 is easy, and 4 times 80 is easy. So we broke it down into numbers that would be easy for us to calculate. Now, let's consider this. What if there was an unknown element? What if, instead of saying 4 times 23, I was trying to figure out what is 4 multiplied by the sum of the value x and 20? Can you set up a vertical algorithm for this scenario? Can you model this scenario with rectangles? So let's try that. 4 multiplied by the sum of the value of x and 20. In vertical form, we're going to say that's 4 multiplied by the sum of x plus 20. Okay, that's how we would do it. And following the same method, we'd multiply the 4 times the 20, and that would give us 80. And then we'd add to that 4 times x. And we'd add them together. And usually we write things with the variables first, so we'd say that that was equal to 4x plus 80. We could also do the same calculation using rectangles. So again, we've got 4, and this time we've got x plus 20. We're going to do the same multiplication. We've got 4x, and then 4 times 20 gives us 80, and then we add those two things together. So we end up with 4x plus 80, just as we did when we used the vertical method. Now, we could take that same equation that we just calculated, where we've got 4 times 20 plus x. Now, if we assume that x is equal to 3, we can say 4 times 20 plus 3 is equal to something. Using the distributive property, we say 4 times 20 plus 4 times 3 is going to give us 80 plus 12, which of course gives us the 92 that we were expecting. We got the same answer. So we've been working with the distributive property, and we can see how it works for us. Remember that the best practice is always to put the variable term first ahead of any constants. Okay, so use that same process to work out these products. The first one's done for you. So you can see here we took the 5 times the 30, and then the 5 times the 4, and we added them together because that's what's being asked, put them together. 5 times 30 is 150, plus 20 gives us 170. Let's look at the next one. We take the 5, we multiply by the 30, then we take the 5, and we multiply by the z. So that gives us 5 times 30 plus 5 times z, which is 150 plus 5z, and we'd rearrange that to put the coefficient in the variable first and the constant second. Next one, 5 times y, 5y, and then we've got 5 times 4, which gives us 5y plus 20. And the last one, we've got x times x. Remember, if we're multiplying two x's together, you get x squared, and then x times y gives you xy. And we're done. Remember, these are not like terms, so we can't go any further in adding things together. Now, this is showing the same kind of problem being done with algebra tiles. So this says we've got x multiplying 3x minus 2. So here's the x. So that x is here. And then the 3x minus 2, here's 1, 2, 3 x's. And then we've got minus 2, which is these two guys right here. So this is a visual way of representing x times 3x minus 2. You can see if you've got x times x, you end up with 1x squared, another x squared, another x squared. Then you've got x over here times negative 2, and that gives you negative 2x. So we end up with, there's our 3x squared, and we've got two negative x's, so negative 2x. Another problem here, 2x times bracket x plus 3. So we set up with our two x's here on the side, And then to show x plus 3, we've got 1x and 3 at the top. X times x gives us x squared. X times this x gives us another x squared. This x times 3 is going to give me 3x's. And the same thing here. This x times those 3 is going to give me another 3x's. So if we put it all together, we see we've got 2x squareds. And we put these together, we've got 6x's. The distributive property of mathematics tells us that a times bracket b plus c is equal to ab plus ac. The value of a is being distributed among the values inside the brackets. Okay, you've got some questions to work through at the whiteboards. Now let's go through the solutions. Okay, for the first one, so we take the 5 times the x and the 5 times the 6 and we add them together. So we've got 5x plus 6. Second one, you get the 3 times the 2x. That gives you 6x. And then the 3 times the 1 gives you 3. Now you've got 2 times 2x. That gives you 4x. And 2 times minus 3 gives you minus 6. Minus 2 times 3x gives us negative 6x. Negative 2 times negative 1, negative times a negative, gives us a positive 2. Negative 10 times 2x is negative 20x. And then negative 10 times 1/5 is negative 10 divided by 5, which of course is 10 divided by 5 is 2. So we've got negative 20x minus 2. And the last one, minus 18 times x gives us negative 18x. And 18 times 2/3, we've got a negative times a negative, so it's a positive 36 over 3, which is equal to negative 18x plus 12. Oh, and I didn't see these two down here at the bottom. 6 times x gives us 6x. 6 times minus 4 is minus 24. And 1/2 times x is 1/2 x. And then 1/2 times minus 4 is negative 4 over 2. So we end up with 1/2 x minus 2.